I know that a lot of students get confused about the shapes of molecules and how to determine the bond angles and the shapes of different molecules. All of this has to do something with the so-called valence shell pair repulsion theory, or the VSEPR theory, which looks at the way that bond pairs and lone pairs repel each other. Remember that the weakest repulsion is between two bond pairs, followed by a repulsion of a bond pair and a lone pair. The strongest repulsion will be between two lone pairs, which will also have an effect on the bond angle. For each lone pair that we add, we decrease the bond angle by approximately 2.5 degrees. The next part is determining the shape and the bond angle based on the number of bond pairs and lone pairs that we have on the central atom. Now, let's take a look at the different scenarios of bond pairs and lone pair combinations. The first scenario is when we have two electron domains, that means two bonds, with two bond pairs and no lone pairs. In that case, the shell will be linear with a bond angle of 180 degrees, and an example of such a molecule is carbon dioxide. Next, we could have three electron domains with three bond pairs and zero lone pairs, in which case we could have a trigonoplanar structure with a bond angle of 120 degrees. An example of this molecule can be boron fluoride. Next, we have four electron domains with four bond pairs and zero lone pairs, in which case the structure is tetrahedral with a bond angle of 109.5 degrees. Methane is an example of a molecule with that structure. Then we can have four electron domains, three bond pairs and one lone pair, in which case we're going to have a trigonopyramidal structure with 107 bond angle. Ammonia is an example of a substance with a trigonopyramidal structure. Then we can have four electron domains with two bond pairs and two lone pairs, like water, which has a bond angle of 104.5 degrees. Next, we have an example of a scenario where we have five electron domains, five bond pairs, no lone pairs. The structure here is trigonobipyramidal with two bond angles, 90 degrees and 120 degrees. Phosphorus pentachloride has a trigonobipyramidal structure. Finally, in the scenario when we have six electron domains with six bond pairs and no lone pairs, we're talking about an octahedral structure with 90 degrees bond angle, and SF6 is a compound that has an octahedral structure. An example of a compound with an octahedral structure is sulfur hexafluoride. Thank you for the attention and stay tuned for more interesting videos like this.